going. Gina, I emailed you with the chapters, right?
Yes.
It was 7, 8, 9, 16, 17?
Yes.
There we go.
Yes, 7, 8, 9, 16, and 17.
There we go. Those are the chapters. Other questions?
Did we get 2 participation quiz grades for coming to class?
For participating in class,
Oh.
just showing up. If you just show up and don't say anything, that's a C class participation grade.
Could you show me my grade after class today?
I actually cannot because my flash drive I left at home this morning because I was in a rush. So,
That's okay.
usually yes.
Okay.
If you email me, we'll apply this afternoon.
Okay, thank you.
Or you can just let it be a mystery.
I hope it's a good mystery. Like Scooby-Doo or something.
Lloyd, that's horrible. That was horrible.
It's not actually a monster, it's something else.
Exactly.
Yeah, I would have gotten away with it. Hadn't been for you.
Meddling kids?
Meddling kids, thank you. Blanket on the adjective.
What about Maggie?
How long could I actually go doing a Scooby-Doo imitation?
Like actual Scooby-Doo, like the, what do you say?
Yeah, of course it probably sounded a lot like Astro from Jetsons.
Jetsons was a good show. I like that one.
All right. Other questions?
Could we maybe go over some questions that we might see similar to the test?
It's called the master sets.
Yeah.
If you have one specifically, I'd be glad to go over it, but I'm not gonna make up a problem on the spur of the moment. There's also old tests that you could go over and pull one from there. But any specific questions?
So, to find the maximum speed and acceleration, is that just, you know how we got our little, equations, it's like negative AW sine and negative, or not negative, but AW squared? Is that just the max?
See context?
I guess this part, the max velocity.
Oh, yes,
The max, okay.
yes. Omega.
You're right.
So her question was around, if I have something in simple harmonic motion and its position is described by a function of time of a cosine omega t plus phi. The velocity would be negative a omega sine omega t plus phi. And acceleration is negative a omega squared cosine. About finding the maximum speed. That's the maximum speed and that's the maximum acceleration. There are other ways of finding it, but if you have the formula right there. I think that is, your question was answered, right?
Yeah.
Okay. That was not a ground entrance.
I know, and I have been told her.
I'm sorry. I'm out of breath from the stairs.
Now, Brian did come in, and so he has another chance of doing the grand entrance when he returns. All right, I will. We talked about simple harmonic motion, something that's oscillating back and forth. It obeys Hooke's law, the fact that the force acting on an object is from the material that obeys Hooke's law, like a spring. The force from this ideal spring is proportional to the displacement and opposite the displacement, where displacement is defined in this context as in how far off it is from equilibrium. We could merge this with a former definition of displacement, but it's unnecessary graffiti on the board. If it obeys Hooke's law, we have a couple of rules that we have figured out. One, that omega is equal to the square root of k over m. And let me just pause, make sure I didn't get that upside down. It's per meter, so it's a kilogram per second squared, so yeah, that feels good. Frequency, 2 pi times the frequency is equal to omega. So omega is equal to 1 over 2 pi square root of, try that again. So frequency is 1 over 2 pi square root of k over m.
It is K.
Pardon?
Sorry, I was,
You were confirming?
yes.
Okay, thank you. You confirmed from notes or?
Good notes.
Okay. What I did, just in case you get into that panic mode, I did it from units, because when you're panicking, units is the first place that you usually go. And I know K as units, this is the spring constant, or basically a stiffness constant, is newtons per meter, which is the equivalent of a kilogram per second squared. The mass here would cancel out the kilograms, and so what I'm left with under the radical is 1 over seconds squared, and then I get 1 over seconds, and I just know that's radians per second. And radians come and go as you please. The period is 1 over the frequency, so this is 2 pi square root m over k. So this is just a recap of some of the stuff last time. And presumably you've seen this in watching the videos, but I do want to go over the simple pendulum. And what makes it a simple pendulum is all of the mass is a point mass at the end of a massless rod, string, whatever this happens to be. So this is massless. Of course, it's frictionless. And this is a point mass. If it's not a point mass, then we'd have to get into moment of inertia and fun stuff like that. So, force diagram. What are the forces acting on the mass?
Tension.
And weight.
And what will be the direction of acceleration?
Perpendicular to tension.
I saw a hand gesture, and what did you say?
Perpendicular to tension.
So that way? Why?
Would have to do with centripetal force?
If we're dealing with centripetal, what would be the direction of acceleration?
Toward.
Toward the
Middle.
in the direction of the string, the tether.
Up here, that way?
Yes.
So if they're centripetal, it's that way, then what acceleration is that?
Centrifugal.
No.
Pendulum.
That's what you said?
That's good.
Somebody might have just said it.
Negative.
Maybe. Because one, if we make it so. All right, so we do have centripetal acceleration going in this direction. That is true because it is changing direction. There is some central point about which it is rotating. But it's also getting faster, so there is acceleration in this direction, and that is tangential acceleration. Now for this particular problem, I only care about the tangential one, but I do want to point out that we do have two accelerations involved here. So working our way down the facades method, we've done the force diagram, we figured out the directions of acceleration. What should our coordinate system be?
In the direction of acceleration.
And so I'll establish I hat and J hat. So we're at the decomposition phase. We have to break up anything?
Wait.
Okay. So let's establish an angle. Typically, in projectile motion problems, it's typical that you give an angle with respect to the horizontal. With pendulum problems, you generally give the angle with respect to the vertical. So that's angle theta there, or that's the angle theta there. So as I'm breaking weight up, that angle there is theta. And whatever I'm breaking up is the hypotenuse. That's not the one I want, these are what I want. So I'm breaking it up into a component that way and a component this way. Because I care about the tangential, since I know where I'm heading, what is that component?
Sine theta.
So we get W sine theta. And the other one would therefore be W cosine theta. So what are my two equations of motion?
Tension minus W cosine theta.
What sign did you put in between them?
Cosine. Only.
FT
Minus.
minus W cosine theta equals
Zero.
not zero. It is accelerating,
Mass times acceleration.
if in doubt. Yeah, it's the mass times, in this case, the centripetal acceleration.
That's where I was getting, I didn't know if it was the tangential or the centripetal.
Now we're dealing with this direction, so it's the centripetal. The other equation of motion?
Omega sine theta.
It's actually W. It's one or the other. I knew what you meant. It's W because it's weight. Not an equation.
Equals zero.
M-
So you're saying, Olivia, you're wrong.
MA.
So-
Oh.
Which A?
AT.
AT.
Yeah.
Great job.
I did that.
Great job, guys.
So Olivia's not wrong. That's what
Olivia's
Olivia's
not
not. All right, now I do care about the second equation right here. We do need to be careful. We have to establish a positive or negative direction here, and I said positive direction, I guess I made j hat in that direction right there. So, well, we're going to have to deal with a minus sign at some point. Because the thing is initially displaced in the negative direction, but it will accelerate in the positive direction, so we will have to come to terms with that. Because technically this is actually not, I wrote theta there, because that, you know, you put up a protractor, that's the angle, but really it's a negative angle. So properly, if I made that direction positive, this is a negative theta. I usually deal with a negative in a different way, and doing it slightly differently this time. So what's the cosine of negative theta? And then what's the sine of negative theta?
Negative mg for
Which one are you doing? The cosine or the sine?
the sine.
Sine, all right. So then you said negative mg
Sine theta equals ma.
Yep. If I drew out the function, if the function is symmetrical about the origin, so you can rotate it 180 degrees and get the exact same thing, then rotate 180 degrees about the origin, it's called an odd function. Odd functions f of negative x equals negative f of x. That odd functions obey this rule. Even functions are that they are symmetrical about the y-axis, not the origin, but symmetrical about the y-axis, like cosine function is. Those are called even functions. And f of negative x equals.
Is that frequency?
No, just functional notation. So what's cosine of negative theta?
Negative cosine theta?
Yeah. Cosine of 30 degrees versus cosine of negative 30 degrees.
Oh, so you would do the 30 minus 360? Because it's
You
one-
could, but don't pull out a calculator if you're not 100% sure. You can use negative 30 on the calculator. You don't have to do 330 degrees.
I got the same thing for both of them.
Yeah.
Oh.
If it's an even function, putting the negative in there doesn't do anything, because it's symmetrical about the y-axis. But if you're going to the negative x direction, well, from your point of view, going to the negative x direction gets you the same place as going to the positive x direction, because it's symmetrical. So this top one right here becomes ft minus mg cosine theta is equal to mac. So the negative does not do anything to the top equation, but for sine, since it's an odd function, it comes out.
Wait, sorry, how do you know if it's gonna be even or odd function?
Symmetry. This is symmetrical about the origin, and this is symmetrical about the vertical axis. That- If you have something that's an even function or an odd function, it allows a couple of shortcuts when you get to calculus. Probably spent too much on even and odd functions. One of the reasons why I probably spent more time on it than I really should have is that when I took the AP Calculus exam back in '81, I did not know the difference. I did not know the terminology even and odd functions, and that's not a problem. So I bring it up now. Okay, so now we're left with looking at that. I got negative mg sine theta is equal to ma sub t, and that does not quite look like this form over here. But we can make it. All right, I have a sub t here. This is tangential acceleration. Think about tangential velocity or linear velocity. If I have something spinning in a circle, the tangential speed is basically the linear speed. If I let go, that's how fast the thing would be going in a straight line. We know that v is equal to omega r. I'm hoping we know that. The change in v is equal to r times the change in omega. We're assuming a constant radius for this problem. So if I have something that has a change in linear speed, which this will, because it starts out at rest and then starts moving, well, I can just divide by the same thing, because the math people say I can. And what I'm left with here is tangential acceleration is equal to r times angular acceleration. Just how rapidly the angle changes. So I'm going to make that substitution. So this now, and I'm going to get rid of my masses. The mass is irrelevant.
That, you said that was alpha, right? And it does what?
Yes. Angular acceleration.